Good evening, ma'am.
Yeah, good evening, Jayant.
Good evening,
Good
ma'am.
evening, children. Yeah, good evening, children.
Good evening, ma'am.
Good evening. All right, so we'll not begin today's session with the discussion of answers to statistics assignment because I'm not sure if all of you have completed it. So I'll continue with real numbers, say till 8:45, and then we'll see the answers on statistics. All right, so today we are going to see the second part of real numbers, which is proving that root 2, root 3, root 5, root 7, that is root p, where p is a prime number, are irrational numbers by the method of contradiction. Okay, so we call this proof by contradiction. Proof by contradiction. And what are we going to prove? We're going to prove that any expression of the form root p, where p is a prime number, any expression of the form root p, where p is a prime number, is irrational, And we're going to prove this by the method of contradiction. So what is that? Am I clear, children? Am I audible? All of you?
Yes, ma'am.
Yeah. I've shared my screen. It's visible, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, children. Thank you. So now when you consider natural numbers, okay, when you consider the collection of natural numbers, we have only two things there. Either numbers are even or odd. In the collection of natural numbers, we have only two types of numbers. Numbers are either even or odd. Now, 5. Now, how do you say that 5 is an odd number? Because it is not divisible by 2. It's not divisible by 2. 5, because if it's an even number, it's divisible by 2. If a number is divisible by 2, then it's an even number. If it is not divisible by 2, it's an odd number. Now, just assume that you have to prove that, listen to this part carefully, because this is how the proof goes for, what we have to continue. That is, prove that root 2 is irrational. And for the others, this is the procedure we're going to use. So I'm trying to explain that procedure using even and odd numbers. Now, supposing we'll have to prove that 5 is an odd number. Prove that 5 is odd. Okay, so you say like this, if possible, let 5 be an even number. So you assume the opposite. See, you know that, okay, now we know that root 2 is an irrational number because its decimal value is a non-terminating, it's meaning its decimal representation is non-terminating, non-repeating. When you find the value of root 2 or root 3 or root 5 or root 7, root 11, root p, where p is a prime number, the decimal expansion of these expressions are non-terminating, non-repeating. And that's why we call them irrational. Because every rational number has a terminating decimal expansion or a non-terminating but a repeating decimal expansion. These are the only three types of decimal expansions we have. We have terminating decimals, we have non-terminating but repeating decimals. And we also have the third category, non-terminating, non-repeating decimals. Terminating decimals, non-terminating but repeating decimals, non-terminating, non-repeating decimals, also called recurring, non-recurring. Non-terminating, recurring decimals. Repeating can be replaced with recurring. Non-terminating, recurring decimals. Non-terminating, non-recurring decimals. So these are the only three types of decimal expansions we have. The first two have a p by q form. This one does not have a p by q form. And we know that rational numbers have a p by q form. A rational number can be expressed in the form p by q. where P and Q are integers, the denominator Q is not equal to 0. Every rational number has a P by Q form. And when you actually divide, see, when we say P by Q, it's a division, right? P divided by Q. So P is the dividend, Q is the divisor. When we say 15 divided by 3, 15 divided by 3, 15 is the dividend, 3 is the divisor. In the same way, P by Q form, meaning P is the dividend and Q is the divisor. So when we divide, we're going to get two things, that is quotient and remainder. When you perform the long division, when we say P by Q form, it is numerator by denominator, where the numerator is the dividend and the denominator is the divisor. Now, when you perform the long division, you get two more things called the quotient and remainder. When the remainder is 0, the quotient is said to be a terminating decimal. When the remainder is 0, see, two things can happen when you divide. The remainder can be 0 or the division goes on and on, meaning it doesn't come to an end with a 0 remainder. These are the only two things possible when you perform the regular long division. So when you perform the long division, when you divide P by Q, two things can happen. The division can come to an end with a 0 remainder, or the division does not come to an end. It goes on and on. It goes on and on. So when the division comes to an end with a 0 remainder, the corresponding quotient will have a terminating decimal expansion. See, even if you get the quotient as 252, it's a terminating decimal because 0.0, 252.0, it's a terminating decimal. Or maybe you'll get something like 15.713672. It's terminating, it ends there. 15.713672, it ends there. See, after the decimal point, you can have even 100 digits, but it ends there. That's important. Terminating decimal means the division comes to an end with a 0 remainder. And when you look at the quotient, it's a terminating decimal, meaning after the decimal point, there is either 0. Okay, so after the decimal point, there is 0. Or if you have some valid digits after the decimal point, they are countable. You can even have 1,000 digits after the decimal point, but there are only 1,000 digits, right? So it's a terminating decimal. It's a terminating decimal because after the decimal point, there are 1,000 digits, fine, but it ends there. And the division has come to an end with a 0 remainder. So when you divide P by Q and the remainder is 0, the quotient is a terminating decimal. Or that P by Q has a terminating decimal expansion. The second case, when you divide P by Q, okay, so you perform the long division, the division does not come to an end. You don't get 0 remainder at all, it goes on and on. In that case, you will see that the remainders are repeating. The remainders repeat, like maybe a single remainder, like the remainder 13 keeps repeating. Maybe the same remainder repeats, or a set of remainders like, okay, so maybe the remainders like 1, 5, 6, and 7 keep repeating. I'm just giving an example. They keep repeating. So maybe, maybe a particular remainder repeats itself, or a set of remainders keep repeating. So when you look at the quotient, supposing 4 different remainders repeat. Okay, so say you get remainders 4, 6, 7, 9, and again 4, 6, 7, 9. You continue the division, so you get the same set of remainders 4, 6, 7, 9, 4, 6, 7, 9, 4, 6, 7, 9. It will go on like that. It will have that pattern. It will have a pattern like that. Either one single remainder keeps repeating, or a set of remainders. It can be 2, it can be 3, it can be 4, it can be 5, it can be 10, 20, 30. Can be any number of remainders. So either one remainder or a set of remainders keep repeating. Why? Because division is not going to come to an end with a 0 remainder. In that case, when you look at the quotient, equal number of digits after the decimal point will keep repeating. So supposing you have 4 different remainders, then you'll have 4 different digits after the decimal point. See, after the decimal point, so supposing the quotient is 12.1, I'm just giving an example, 6132. Okay, so again, 6132 in the quotient. If you have 4 different remainders, in the quotient also you will see not the same digits as the remainders, something else. Okay, so the digits like 6132 keep repeating in the quotient because you have 4 different remainders, 4 different digits in the quotient, 6132, 6132, 6132. 4 different remainders keep happening. 4 different digits in the quotient keeps repeating. So that's why we say 12.6132 recurring. We put a bar, or you have to place dots like this. If you simply write 12.6132, 6132, and 6132 and stop there, it's a terminating decimal. If you say 12.6132, 6132, 6132, it's a terminating decimal. Because there is no indication that it's recurring. You have not indicated that it's recurring. 12.6132, 6132, 6132 finished. Terminating decimal. So you'll have to indicate. You cannot say, see, I've written it 3 times. No, that means it's repeating. No, you've written it 3 times, but it's stopped there. What is the indication that it's repeating? It's going on forever. So you need to use these dots or place a bar like this. So the bar indicates that the digits 6132 repeat themselves. Or when you place dots like this, that also suggests that this pattern, because you'll have to write the pattern once. You cannot write 12.6132 and then place the dots. This is confusing. What repeats? 2 repeats, 32 repeats, 132 or 6132. So you need to repeat that pattern. So whatever, like 16.6132, at least once you should write it once more and then place the dots. Somebody's mic is enabled. Please disable your mic. Pushita? Yeah, Pushita, please disable your mic.
It's disabled.
Oh, okay. No, because I can hear the noise from the background in your place.
Okay.
Yeah, thank you, Pushita. Yeah, children. So I was telling you that you need to give that, indication that a set of which digit or the set of digits repeat. So 16.6132, and if you do this, it's not clear as to which digit or which set of digits repeat themselves. So you need to write that set at least once like this and then place the dots. So here it's clear that 6132 keeps repeating. Don't place the bar and the dots. So you can write the 2 ways of writing it are, if it is recurring, 16.6132, 6132 like this, or 16.6132 and place a bar like this. Don't put the bar and put the dots and no. All right. So when we have P by Q division, okay. So either the division comes to an end with a remainder, a 0 remainder, or you don't get a 0 remainder at all. You don't get a 0 remainder at all. The division keeps going on and on. When you get remainder 0, the quotient is a terminating decimal. The quotient is a terminating decimal. When you don't get remainder 0, the division goes on and on. Then the quotient is a non-terminating but repeating decimal, because either one digit or a set of digits repeat themselves. So P by Q means division. Division means quotient and remainder. Remainder means 0 remainder or non-zero remainder, meaning it goes on and on. If the remainder is 0, terminating decimal. You're not getting 0. Remainders keep happening. Then it's a non-terminating repeating decimal, because you can see that in the quotient, either one digit, if one remainder repeats, only one digit will repeat in the quotient. Two different remainders are repeating, 2 different digits in the quotient will repeat. So these are the only 2 cases possible when you perform the long division. Either you will get the quotient as a terminating decimal, or the quotient will be a non-terminating but repeating decimal only. then when will you get a non-terminating, non-repeating decimal expansion? They are the values of irrational numbers. Okay, the value of root 2. Now we know how to find the value of root 2, right? 8th standard long division method. We have learned the long division method to find the value of root 2. So when you find the value of root 2, you see that the decimal expansion is non-terminating, non-repeating. It's not the regular long division. We have a special method to find the value of root 2. That is the square root of 2. You know, it's 1.414 and goes on like that. It goes on, but you don't see a digit or a set of digits repeating themselves. So it's like, from where do we get terminating decimals? By dividing p by q. From where do we get non-terminating repeating decimals? Again, by dividing p by q. From where do we get non-terminating, non-repeating decimals? Not from p by q, not by dividing p by q. When you divide p by q, you cannot get a non-terminating, non-repeating decimal. They are the values of root 2, root 3, root 5, root 7. So when you find the values of these expressions, you will see that the values are non-terminating, non-repeating, meaning a digit or a set of digits will not repeat themselves regularly. There's no pattern in the the decimal block. In the decimal part, there is no pattern. Okay, so this is what is real numbers. So the two real numbers are broadly classified as rational numbers, and irrational numbers. Don't write anything. You will get all these notes. Don't write anything. Just listen. Just listen. Okay, so real numbers are classified as rational numbers and irrational numbers. Rational numbers have a p by q form. Irrational numbers do not have a p by q form. The decimal expansions are terminating or non-terminating but repeating. Here it is non-terminating, non-repeating. Okay. So rational numbers and irrational numbers put together are called real numbers. And real numbers are the numbers that exist. Real numbers are the numbers that exist. There are numbers also called imaginary numbers, which you will be learning after 10th standard. So there's something called imaginary numbers. So our study is restricted to till standard 10. Our study is restricted to real numbers, that is numbers that exist. So real numbers are classified as rational and irrational. Rational have a p by q form. Irrational do not have a p by q form. Decimal expansions of rationals are terminating or non-terminating, repeating. Irrational numbers have only one form of decimal expansion, which is non-terminating, non-repeating. So coming back to our discussion, we have to prove that any expression of the form root p, where p is a prime number, any expression of the form root p, where p is a prime number, is irrational. Okay, so like real numbers are only two things, rational or irrational. If something is not rational, it is irrational, because we're talking only about real numbers. We are not talking about imaginary numbers. We are talking only about numbers that exist. So in our study, we have only two numbers, rational numbers, irrational numbers. So supposing you get hold of a number and you see that it is not rational, that means it's irrational. That means it's irrational. If it's not rational, it is irrational. So that's what we're going to prove. Root p, where p is a prime number, is always irrational. Okay. Now for that, I was telling you, let's take the collection of natural numbers, wherein numbers are either even or odd. If a number is not even, then it's odd. Now, when you take this number 5 or 7, for example, when you divide by 2, remainder is 1. If the remainder is 0, it is even. If the remainder is 1, it's odd. We know that. So if you take a number and you divide by 2, 101, when you divide by 2, the remainder is not 0, it is 1. The remainder is 1. So since when you divide by 2, you want remainder 0 to say it is even. If the remainder is not 0, it's 1. See, here you will get remainder 0 or 1. When you divide by 2, you can only get these two remainders, 0 or 1. You cannot get 2 as a remainder, right? When you're dividing some number like 137, the maximum remainder you can get is 136. You can get 0 as a remainder, 1, 2, 3, 4, 5, 6, 7, 8. Remainder can be anything but less than the divisor. The divisor is 137. So remainder cannot be 137 or more than 137. When you're dividing by 137, you cannot get 137 as a remainder, or you cannot get anything more than 137 as a remainder. So the remainder can be maximum 136. So similarly, when you divide by 2, only two things can happen. Either remainder is 0 or 1. You cannot get 2 as a remainder. When you divide by 2, you cannot get 2 as a remainder. So any number when you divide by 2, either the remainder is 0 or 1. If the remainder is 0, it's even. If it's not 0, that is it's 1. It's not 0. It's odd. Because when we talk about natural numbers, there are only two things. Only two things are possible. Numbers are either even or odd. So if it is not even, it's odd. If it is not odd, it's even. In the same way, when we talk about real numbers, they're either rational or irrational. If it's not rational, it is irrational. If it is not irrational, it is rational. Now let's see how much you remember. Is that clear, children? All of you?
Yes, ma'am.
Yes, ma'am.
Yeah. Sashank and Pushita?
Yes, ma'am.
Okay, my screen is visible, right?
Yes, ma'am.
All right. Okay, and what about Sashank? My voice is reaching you clearly, Sashank? No problem. I'm not able to hear you. No problem. I'll check with you later. Okay. Now, is basic questions, okay? Is this an integer? Quickly. 4 by 7. No. 4 by 7 is not an integer. Is this a rational number?
Yes, ma'am. Because it's of the
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
It is a rational number. What about this? Is this a rational number?
Yes, ma'am.
Yes, ma'am.
Okay. All right. Is this a rational number?
No, ma'am. Yes, ma'am. Yes, ma'am.
Is this a rational number?
Yes, ma'am.
Yes,
It can be
ma'am.
expressed as 15 by 10.
Yes, ma'am.
Why is it rational?
Give me a rest.
15 by 10.
Yeah, because it's a terminating decimal.
Because it has a terminating decimal.
Very good, very good. Who was that? Sashank, is it?
Yes, ma'am.
Very good, very good. Yes, because it's a
my
terminating decimal. Yeah, because it's a terminating decimal. 1.5 is a terminating decimal. Yeah, and somebody else said it's 15 by 10. Perfect, yes. Because you can write it as a fraction. You can write it in the p by q form, which simplifies to 3 by 2. So 1.5 is a rational number because it's a terminating decimal. Or you can say because it has a p by q form, which is 3 by 2. Both are fine. Is this a rational number? 1 minute. Let me finish writing. Is this rational or irrational?
Rational.
Rational.
Rational number, ma'am.
Rational number.
Why?
Rational number.
It's a
Ma'am, terminating and repeating, ma'am.
No. When we say terminating, you know, when it's terminating, it's only terminating. Only if it is non-terminating, you can say repeating and non-repeating. Okay, let me write that 1 minute. Let me write that 1 second. See, here, terminating is only terminating decimal. Non-terminating repeating, non-terminating, non-repeating. In terminating, we don't have terminating, repeating, terminating, non-repeating. We don't have that. There's nothing like that. Terminating decimal is only terminating decimal. Terminating decimal is only terminating decimal. If you say it's a non-terminating decimal, then you should specify. Is it non-terminating repeating or non-terminating non-repeating? If you say terminating, that's it. It's a terminating decimal. If it's non-terminating, you should specify. If it's repeating or non-repeating. Sometimes we just say it's a repeating decimal. We'll only say it's a repeating decimal. Repeating means it's understood, it's non-terminating. You should not ask, okay, it's a repeating decimal, is it rational or irrational? Sorry, it's if it is terminating or non-terminating. The terms repeating, non-repeating, recurring, non-recurring, they're used only with non-terminating decimals. Non-terminating decimals can only be non-terminating repeating or non-terminating non-repeating. So when we say repeating decimal, that means it is non-terminating repeating. When we say non-repeating decimal, it's understood it is non-terminating, non-repeating. If you simply say non-terminating decimal, then you should specify non-terminating, fine. But is it non-terminating repeating or non-terminating non-repeating? But if you say repeating, it's understood it's non-terminating repeating. If you say non-repeating, it's understood it's non-terminating non-repeating. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah, but you don't write repeating decimal in the exam. I'm just telling you, we should always write non-terminating, non-repeating or non-terminating repeating. I'm just telling you, just in case you come across this repeating decimal. So you should understand it is non-terminating and repeating. That's what I meant to say. So this one is simply a terminating decimal. That's it. Terminating decimal. What about this? This one?
Terminate.
Terminating.
Terminating. What about this one?
Non-terminating.
Non-terminating recurring.
Non-terminating repeating or non-terminating recurring. A lot of difference between this one and this one. They're not the same. So this one is a terminating decimal. While this one is 1.1 recurring. One recurs, one goes on and on and on infinitely. 1.1 recurring means 1. The digit 1 after the decimal point goes on and on and on. It doesn't end. That is 1.1 bar. 1.1 bar, meaning 1 goes on and on. Here, 1, it stops here. So this is terminating. This one is non-terminating, repeating. Or you can also write it like this, 1.11, and then you can put dots like this. That means, see, you've given the clue, 1, 1. So that 1, 1 is going on repeating. 1, 1, 1, 1 goes on forever. Okay, so now we are going to understand how to prove. Yeah, I was telling you that when you divide by 2, if the remainder is 0, it is even. If it is not 0, it is odd. So in the same way, if you supposing you assume that root 2, see, we know that root 2 is rational. How do we know that root 2 is, we know that root 2 is irrational. We know that root 2 is irrational. Why? Because we know its value, its decimal expansion is non-terminating, non-repeating. The value of root 2 is a non-terminating, non-repeating decimal, and hence it is irrational. We know that. How we know? Because the value is non-terminating, non-repeating. Now, how do you prove that? So in your syllabus, you have this proof by contradiction. So what is that contradiction? You're going to assume the opposite. You're going to assume the opposite. You know that root 2 is irrational, but you're going to say, if possible, let it be rational. If possible, let it be rational. Okay. It's like you get hold of a cat. And you're saying it's a dog, but it will not bark. And it's more gentle, right? Than I'm not hurting any pet lovers, but it's said to be more gentle than a dog. So it goes on like that. No, so you have, and it's more furry or whatever. It has whiskers. So if you get hold of a cat and say it's a dog, the features are so different. In the same way, when you assume, you know that root 2 is irrational, but when you say it is rational and you proceed working, something contradictory will happen. Because when you get hold of the cat and say it's a dog, you wanted it to mew, but it will bark. You got hold of a cat and you're assuming it to be a dog. So since you assumed it to be a dog, you want it to bark, but it will mew. So opposite things will happen. You'll be expecting something because it's a dog, but it's not a dog, it's a cat, so it'll be doing something else. In the same way, root 2 is irrational, but you get hold of root 2 and say, no, you're rational. So when you work with that, something contradictory will happen. So you say that because by mistake, so you will say, by mistake, I got hold of a cat and I thought it's a dog. So it's not a dog, therefore it's a cat. In the same way, when you work believing that root 2 is rational, so you will come across some contradiction, something which is not true about a rational number. When you assume it is rational and you work, as you work, you will come across situations which are not true for a rational number, Okay, so then you will say, okay, I thought it is rational, but when I assume it's rational and when I work it, I'm getting cases or I'm getting a case or cases where, it is not rational. So it's irrational. So it is irrational. So you're not directly proving it's irrational. You're proving that it is not rational. You're assuming it is rational, but your assumption is wrong. For some reason, your assumption is wrong. So then you say, okay, I was wrong. It's not rational. Then what is it? It is irrational. That's what is proof by contradiction. That is what is proof by contradiction. And to understand this, you need to know a theorem. I'll just tell you the result of the theorem now. Is it fine so far, children?
Yes, ma'am.
Yeah. All right. Okay. So now we need to understand that if a prime number, okay, so I'll just write it. If a prime number P divides a square, then P also divides A. Let's understand what it is. Now, say, I'll take this number, something easy, 81, okay, 169 is 13 into 13, 1 second. Let me take 400. Okay. Now, what is 400? It's 20 square, right? 400 is 20 square. 400 is 20 square. Okay. Now tell me a prime number. Tell me a prime number that divides 20 square. See, 20 square is 400. 20 square is nothing but 400. Now take the prime number 5. 5 is a prime number. Okay. Now does it divide 400? Yes, it divides 480 times. Now if 5 divides 400, that means 5 will also divide the square root of 400, which is 20. See, read that. If a prime number p divides a square is a square number. A square meaning a square number. A square means a square number. If a prime number p divides a square, that is a square number, then the same prime number p will divide a. Will divide a square a. What? A square a, how are they related? A square is a square number, a is the square root. If a square is 400, a is 20, because 20 into 20 is 400. If a square is 169, a is 13. If a square is 36, a is 6. So the theorem is if a prime number p divides a square, then the same prime number p will divide a. So we have taken this number 400, which is 20 square. 20 square. Okay. Now this prime number 5 divides 400. 400 by 5 is 80. Divides meaning exactly. Remainder 0. Okay. So the prime number, not any number, prime number. So the prime number 5 divides 400 80 times. So that means the same prime 5 will divide the square root of 400, 20. Yeah, correct. 20 by 5, 4. Now you can try this for anything. Now, for example, 36. 36 and 6. Okay, 36 is the square number, which is a square. 6 square. So a is 6. A square is 6 square. So a is 6. So now the primes 2, 3, 2 and 3 are prime numbers, correct? And 36, 2 and 3, they divide 36. 2 and 3, they divide 36. 36 by 2 is 18. 36 by 3 is 12. So the primes 2 and 3, they divide 36. That means the same primes 2 and 3 will divide 6. Yes, 6 by 2, 3. And 6 by 3 is 2. All right, children. So that's what is the meaning of this theorem or the statement. If a prime number p divides a square, then p also divides a. If a prime number p divides a square, then p also divides a. Am I clear, children? To all of you?
Yes, ma'am.
Yes, ma'am.
All right, children. Very good. Now we are ready to understand this proof by contradiction. Having recalled all this, we are now ready to understand this proof by contradiction. Listen carefully. You must listen as if you don't know anything. So if you've already learned it in school and you're having that in your mind and trying to understand this, don't do that. I don't want you to do that. Just listen to me as if you know nothing, meaning nothing about the proof. Okay. All right. Now, children, so since it's proof by contradiction, we assume the opposite. If possible, let root 2 be the next proof you're going to write by yourself. The next one you're going to write by yourself. Listen to this carefully. If possible, because if you take 7 and say let 7 be an even number, you're wrong. 7 is odd. How can you say it's even? So you must say if possible. If possible, let 7 be an even number. So like that, if possible, let root 2 be rational because we know it is irrational. Non-terminating, non-repeating decimal. We know it's irrational. If possible, let root 2 be rational. Now, what's the definition of a rational number? It has a P by Q form or A by B form. You can write anything. M by N, you can write M by N form, A by B form, P by Q form, X by Y form, anything. Anything, P by Q, anything is fine. So then root 2, because you're saying it's rational, it will have an A by B form or a P by Q form, anything you can write. So it will have A by B form where A and B are integers and the denominator B is not equal to 0. So when we say co-prime integers, now I'll have to tell you this. What are co-prime integers? Co-prime integers are if two numbers. Okay, what are co-prime integers, children?
The two
Not bad.
numbers have only one.
They have common factor 1, ma'am.
Very good. If the HCF, very good. I heard that common factor 1. Who was that?
Danya, ma'am.
Very good, very good. Children, I'm getting a call. Just a minute, please. I'll get back. Yeah, thank you, children. Yes. So, yeah, I started explaining right. One second. Oh, yeah, I was asking about co-prime numbers. Yes, and I got the answer from you. So you all said if the HCF of two numbers is 1, if the HCF of two numbers is 1, then the numbers are said to be co-prime. Correct. So now 6 and 10. No, not 6 and 10. So 6 and 7, are they co-prime? No, 9 and 10, are they co-prime? 9 and 10.
Yes, ma'am. Yes, ma'am.
But 9 is not a prime number. 10 is also not a prime number. Nine and 10 are not prime numbers. Then how will you say they are co-prime? HCF is 1. HCF is 1, but they're not prime numbers. No. Then how can you say they're co-prime? Yes, who can say? So you must tell me that.
Consecutive numbers are always co-prime.
Yeah, consecutive numbers are always co-prime. That's correct. But my question is 9 and 10 are not prime numbers. Then how can you say they're co-prime?
Ma'am, but their common factor is only 1.
Okay, so the answer is there's only one condition for two numbers to be co-prime. If their HCF is 1, they're co-prime. There is no other condition. They need not be prime numbers. The two numbers need not be prime numbers. Two numbers are said to be co-prime if their HCF is 1. That's it. That's the only condition. If the HCF is 1, they are co-prime. There is no condition that the numbers must be prime numbers. They may be prime, but they need not be prime. They need not be prime numbers. They can be a combination of two prime numbers or two composite numbers or one prime and one composite. Anyways, their HCF should be 1. If HCF is 1, they are co-prime. They need not be prime numbers. They may be prime, but they need not be prime. There's no condition that they have to be prime. Okay, so that's the condition here. Okay, so rational. So we know that if you assume, we know that root 2 is irrational, but we are assuming the opposite. Let it be rational. Then if it is rational, it has an A by B form, where A and B are co-prime integers. That is, this is a short way of saying where A and B are integers and B is not equal to 0. A and B are integers, and when we say A by B, it's always the simplest form. Remember that. When we say A by B form, it's always the simplest form. Remember, we do never write 100 by 200 as the answer. We don't leave the answer as 100 by 200. If you get, supposing you work and you get the answer as 100 by 200, you will never leave it there. You will always simplify it, and you will say it's equal to 1 by 2. So when we say A by B, it's always the simplest form. Root 2 is equal to A by B. A by B meaning simplest form, where A and B are co-prime integers. A by B is the simplest form. That means what? You cannot simplify them any further. They don't have any common factor. That's why we say they're co-prime integers. Their HCF is 1. If their HCF is 1, that means they have nothing. You cannot cancel it any further. Like it's not like 10 by 12. Because 10 by 12 HCF is not 1. You can cancel, no? 5s are 6 are. Now 5 by 6, the HCF is 1. HCF is 1. So it's in the simplest form. That's why we are saying co-prime integers. That means that HCF is 1. And integers means A and B are integers. See, everything is here. What are A and B? They are integers. See here, co-prime integers, meaning A and B are integers. A and B are integers because see, we are saying A and B are co-prime integers. So A and B are integers, And they are co-prime integers, meaning their HCF is 1. That means they cannot be simplified any further. So it's understood. And B cannot be 0 because when you're saying co-prime integers, HCF is 1. So the denominator B cannot be 0. So everything is included here. When you say A and B, where A and B are co-prime integers, everything included. They are integers. They are in the simplest form. Okay, now let's square that on both the sides. Square this on both the sides. Root 2 the whole square is equal to A by B the whole square. So what do you get? Root 2 square is 2. And this one is A square by B square. Cross multiply. When you cross multiply, you get A square is equal to 2B square. A square is equal to 2B square. Now, what do we understand from this? A square is equal to 2B square means 2 divides A square. See, now, again, I'll have to tell you something else. Now, supposing 24 is equal to 2 2s are 4, 4 2s are 8, 8 3s are 24. Okay, so now 2 divides 24, 3 divides 24. Because you can see it here. 2 divides 24. See, it's the other way of saying 24 is divisible by 2. So see, there are so many things. I think 1 minute. When I said 30 is a multiple, 30 is a multiple of 6. 6 is a dash of 30. What of 30?
Factor of 30.
Factor of 30. Very good. Factor of 30. 30 is a multiple of 6. 6 is a factor of 30. A is B's father. Then B is A's
Son.
Son.
why not daughter?
Child.
Child. Yeah. Okay. If A is B's father, then B is A's child. Can be son or daughter. Okay. So 30 is a multiple of 6. 6 is a factor of 30. In the same way, when we say, okay, I'm taking a different number, say 50. 50 is 2 into 5 into 5. Okay. So we say 50 is divisible by 2. 50 is divisible by 5. The other way of saying is 2 divides 50. 5 divides 50. So I think we are more used to this, right? 50 is divisible by 2. 50 is divisible by 5. When you use the word divisible, you say the bigger number first. 50 is divisible by, so the bigger number first and then the smaller number. 50 is divisible by 2. 50 is divisible by 5. The other way, 5 divides 50. 2 divides 50. So how do we say that 2 divides 50? Because there's a factor 2 here. How do you say that 5 divides 50? Because here 5 factor is there. Is this clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah. So now, so don't we see the prime factor 2 here? Yeah, don't we see the prime factor 2 here? A square is equal to 2b square. That means what? A square is divisible by 2 or 2 divides a square. 2b square meaning 2 into b into b. 2b square meaning 2 into b into b. So what are the two ways of saying a square is divisible by 2? Or you can say 2 divides a square. Yes or no, children?
Ma'am.
That's what it is. So because you see the prime factor 2 here, 2 divides a square. But what have we learned earlier? If a prime number divides a square, then that prime number will also divide a. The theorem which we learned some time back. So since 2 divides a square, 2 also divides a. 2 divides a square. There's a different theorem we just understood. If P divides A square, where P is a prime number, where P is a prime number. If P divides A square, then P divides A. P divides A. A square is a square number. A is its square root. So that's the situation we have here. 2 divides A square. If 2 divides A square, it's a prime number divides A square. Then the same prime number will divide A. So 2 divides A. 2 divides A. Okay. Now our task is to prove that 2 also divides B. 2 also divides B. If 2 divides A and B, then it's a contradiction because we have assumed that, because we know that A by B is the simplest form. The HCF is 1. The HCF of A and B is 1. But if you prove that A and B have 2 in common, it's a contradiction. That's because we have assumed, root 2 to be rational incorrectly. Therefore, it is irrational. That's what we're going to do. We have now got this result that 2 divides A. That's fine. Let 2 divide A. That's okay. Now, for example, in 10 by 13, in 10 by 13, this is simplest form. But 2 divides 10. That's fine. You should prove that 2 also divides 13. 2 can divide 10, but this is the simplest form. So it's not enough if you prove that 2 divides the numerator 10. You must also prove that you should also prove that 2 divides the denominator 13. So here you'll have to, we've got this result that 2 divides A. So next we're going to prove that 2 divides B. If 2 divides B, A and B both have 2 as a common factor. But how is it possible? A and B are co-prime integers. Their HCF is 1. Then how can they have 2 as a common factor? So this is a contradiction. This is a contradiction, meaning it contradicts the fact that A and B are co-prime. If both A and B have 2 as a common factor, it is contradicting the fact that A and B are co-prime. Their HCF is 1. Then how can both of them have 2 as a common factor? So it's contradictory. Why this contradiction? Because we have assumed root 2 to be rational incorrectly. Therefore, it is irrational. This contradiction, this opposite, this clash happens because our assumption is incorrect. What we have assumed is incorrect. It's wrong. So root 2 is rational is wrong. Therefore, root 2 is irrational. This is how we prove that root 2 is irrational by the method of contradiction. So 2 divides A. Now let's proceed to prove that 2 also divides B. 2 divides A, 2 also divides B. So now, what do you mean by 2 divides A? 2 divides A meaning you can write A as something like 2C. A is equal to 2 into something. 2 divides, it's a continuation. From this result, we are continuing. From this result, 2 divides A. Again, 1 minute. Now, if I say that, 12 is equal to 2 into 6. 2 into 6. So 2 divides 12, right? So you're able to write 12 as 2 into something. If 2 divides A, that means you can write A as 2 into something. Now, see here, 3 divides 15. 3 divides 15. That means you can write 15 as 3 into something. 3 into 5. 7 divides 56. 7 divides 56. That means you can write 56 as 7 into something. You can write 56 as 7 into something, 7 into 8. In the same way, since 2 divides A, 2 divides, 1 second. Yeah, so since 2 divides A, that means you can write A as 2 into something. And that something, don't use A or B again. Use some other letter. So C. If you've used P and Q, you can use R. If you've used X by Y, you can use Z. So here I've used A and B, A by B, no? So I'm just saying it's C. So since 2 divides A, that means you can write A as 2C, 2 into something. Now square this one on both the sides. So you will get A. See, this one we are writing from this result, children. Don't think suddenly we are writing A is equal to 2C. Because we know that 2 divides A, 2 divides A, that means you can write A as 2 into something. And that something we are calling it as C. Now this result you square on both the sides. So you get A square is equal to 2C the whole square, 2C into 2C, which is 4C square. 2C into 2C, which is 4C square. All right. So A square is equal to 4C square. But we know that A square is equal to 2B square. See, we want to introduce B because we have to prove that 2 divides B. Now in this equation, there is no B at all. Then why are we proceeding? What is that, what is that we want to prove or show? We want to show that 2 divides B also. 2 divides B, but there is no B in this equation at all. There is no B at all. So we're somehow trying to introduce B. How are we going to do that? A square is equal to 4C square, but we know that A square is 2B square. So like that, we're trying to bring in B. We're trying to bring in B. So A square is equal to 2B square. So see here, this one. So instead of A square, we say 2B square is equal to 4C square. So now 2 1s are 2 2s are, you can cancel, right? So B square is equal to 2C square. You can cancel. This 2 will come here for division, right? This 2 will come down here for division. So B square is equal to 2C square. B square is equal to 2C square, children. This 2 will come down here for division. So 2C square. B square is equal to 2C square. Now we got something. So B square is equal to 2C square, meaning 2 divides B square. Because B square is 2 into something. B square is 2 into something. So that means 2 divides B square. That means by the theorem 2 also divides B. If 2 divides B, if a prime number divides B square, then that prime number also divides B. So 2 is a prime number, it divides B square, so it should also divide B. It should also divide B. Now 2 divides A, 2 divides B. No, that's not possible. So from 1 and 2, from 1 and 2, see, from 1 and 2, 2 divides both A and B. We have proved that. We've got those results. 2 divides both A and B. This means A and B have at least 2 as a common factor. We see, maybe it has many more common factors. We have shown or we have proved that it has at least 2 as a common factor. Okay, so we have shown that A and B have A and B, the numerator and the denominator, they have at least 2 as a common factor. This contradicts the fact that A and B are co-prime. We started saying that A and B are co-prime. So this contradicts. This is opposite to the fact that A and B are co-prime. Why this contradiction? This contradiction, this is due to, meaning this contradiction is due to our incorrect assumption that root 2 is rational. Hence, root 2 is irrational. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
All right, children. So that's what it is. The same is for root 3, root 5, whatever, root P, where P is a prime number. Similar proof. Just that the numbers, now here we have 2 and 4, right? So when it is 3, you will have 3 and 9. If it's 11, it will be 11 and 121. So the numbers will change. So I want all of you, the rest of you, other than Sashank and your Tushita, right? TUS. This is your spelling, Tushita? TUSHITA?
Yes, ma'am.
Okay. All right. So Tushita and Sashank, other than Tushita and Sashank, the others have written all this in your book, right? You remember last class we wrote down all this? Yes or no, children?
Yes, ma'am, but only root 11's proof was given, ma'am.
Yes, ma'am.
Oh,
Yes, ma'am.
thanks for. Oh, really? I didn't know. Okay, children. Root 2 was not given, is it?
Root 2 to root 7, only the question was written. Only root 11, there was the proof, ma'am.
Oh, then that's good. Then all of you. Yes, children. Now take down this. Have a look at the proof once again. Understand and then write it down in your book. I'll give you 7 minutes for that. I'll just show you a glimpse of root 3 so that you can do this by yourself. Just read through this. I'm sorry to disturb you, and just read through this. So here, when you square on both the sides, you'll get a square is equal to 3c into 3c. 3c into 3c is 9c square. And then this a square you should replace with 3b square. A square is equal to 3b square. So a square becomes 3b square. 3b square is equal to 9c square. Then this 3 will come here for division. So all those so many steps you don't have to show. You can directly write this. Whatever I have written here, that is enough. I'm just telling you how we get the next step. So this 3 will come down for division here. So 3 3s are 3c square. So b square is equal to 3c square. So 3 divides b square, 3 divides b. So 3 divides both a and b. So at least 3 as a common factor. It's a contradiction. Yeah. Isn't it similar, children? Just that here you get 3 and 9. Now, with the help of this one, please try to work all this by yourself. Root 2, prove that root 2 is irrational, root 3, root 5, root 7, and root 11.
Okay.
Yeah, just make a note of the numbers. Root 2, root 3, root 5, root 7, root 11. 2, 3, 5, 7, 11. The first 5 prime numbers. Okay. So this proof will be visible for you. You can take the help of this. The numbers will change. Please take care. If you practice something incorrectly for the first time, that will get registered in your mind. And to unlearn that becomes very difficult. If you register something incorrectly, mostly when you learn something for the first time, however you understand that you retains in your mind, then it becomes difficult to unlearn that. So learn it correctly. This is for 2. For 3, you will get different numbers, 3 and 9. For 5, you will get 5 and 25. Yeah. So this root 2 proof is visible to you. Use this and try root 3. Complete this one and then try root 3, root 5, and root 7. I'll come back in 10 minutes. All of you must work, and if possible, take pictures of your classwork and put it on WhatsApp for me so that I make sure that you're all working. If a phone is available with you, please take a picture of whatever you're working now, root 2, root 3, root 5, and root 7, and share it with me on WhatsApp. I'll be happy to see that. Yeah, get started, children. I'll come back in 10 minutes. Get started. Yes, all of you share the pictures on WhatsApp. I want to know what you worked so far. At least one you should have finished. Root 2.
Yes, ma'am.
Yes, children.
I'm working root 7.
Root 7. Okay. Yeah, I'll be happy to see the pictures, children. Just
Ma'am,
pause,
5.
grab the mobile phone. You can send from a different number also. I just write your name, that's all. If you're sending from a number different from what you're given me, it's okay. Just write your name. Yes, stop working and send the pictures. I want to see the pictures, children.
Ma'am, should we work out the 11th one too?
You mean for root 11, huh?
Ma'am.
You already have it in your book. If you want to practice, you can do it again, but not needed from my end. Yeah.
Okay, ma'am.
Yeah.
Completed, ma'am.
Yeah, Madhumita, good. Just waiting for the others to complete. All if you finish and let me know. I'm right here.
Completed, ma'am.
All right, Raghavi.
Completed, ma'am.
Okay, so Madhumita, Tanishka, Danya, and Raghavi. Waiting for the others.
Ma'am, I have also completed, ma'am.
Okay, good, Ritika.
Completed, ma'am.
Rakshita, is it?
Yes, ma'am.
Good, good. Okay. Yeah, those who want to take a picture of the answers can do so. Root 2 already, I think you have used the, the PPT to write. This is for root 3. Please take a screenshot if you want for your reference. If you want to check your answer with this one, please.
Ma'am, completed till 11.
Yeah, very good, Sashank. Yes, yes. No, I've not received the pictures from all of them. So I'll read out. So I've got it from Raghavi, Prajit, Arjun, Rakshita, Ritika, Madhumita, Tanishka, Tushita, and Sashank. Florentina. Who are the others who have not sent? Okay, Prajit is sending now. Florentina, Giant, Raja. You don't have a phone now, Raja?
Yes, ma'am.
Okay, okay.
Ma'am, can I
Krishmi?
send after the class?
Yeah, please do that. Yes. What about Krishmi? You'll send later, Krishmi? Okay. Fine. I'm not able to hear you, but I'm sure you heard me. Students have not sent the pictures now. Kindly send it after the class. For everything, root 2, root 3, root 5, root 7, and root 11. All. Don't see some, one funny thing happened last year. When I asked children to share, one of the children shared the screenshots. I couldn't help but laugh. When I said share the pictures, the child shared the screenshots which, he had taken during the class. So you came to know it's a boy. So now I asked you all not to take screenshots. So this child on WhatsApp shared the screenshots with me. I said, not screenshots, what you have worked in your book. Then I got it the next day. So please understand me right. Yeah, this is for root 7. Yeah, please take a screenshot, children, just for your reference. Maybe you have to check. You are working with the correct one, so please take a screenshot. This is 7 and this is 11. All right, nice children. Let's proceed. Yeah. Now look at this. Prove that root 2 is an irrational number. So now we know how to prove. You have only this one proof by contradiction, by the method of contradiction. You have only this proof. So prove that root 2 is an irrational number. So you'll have to use this. See, you are not supposed to find the square root by long division, though that's also right, though that's also right. You can find the square root of 2 by the long division method. And then you can say that, see, I'm getting a non-terminating, non-repeating decimal. So it is irrational. That's correct. But 10th standard, you're not expected to do that. You are expected to present the proof by contradiction, what we just learned. So this is also correct. This is correct, but you're not expected to do this. You can perform the long division and show that, this this decimal expansion is non-terminating, non-repeating. But don't do that. Okay, so you'll have to work the proof by the method of contradiction. So prove that root 2 is an irrational number. Okay, we can prove that. Hence show that. So now what happens, this one acts as a theorem. This one acts as a theorem. You have proved, right? That result acts as a result for a theorem statement. Hence show that 3 by root 2 is also irrational. Hence show that 3 by root 2 is also irrational. Okay. So see, children, when you divide, is this one irrational? 2 root 5?
Yes, ma'am.
Is root 5 irrational?
Yes, ma'am.
But the quotient, when you divide this irrational by this irrational, the quotient is rational.
Yes, ma'am.
In this example, not always. Oh yeah, I have this question for you now. Is this okay? Now this 3 by root 2, it's of the form P by Q, right? Or A by B? Correct?
Yes, ma'am.
Yes, ma'am.
Then it's rational, right?
Both should be an
No,
integer.
ma'am. A.
Yeah.
Both of them should be integer, but the B is not an integer.
Yeah, very good. So 3 by root 2 may look like something by something, but both the numerator and denominator have to be integers for it to be a rational number. When we say P by Q form, it is integer by integer form. Integer by integer is a rational number. P by Q form, meaning integer by integer form. Integer by integer form is a rational number. Of course, the denominator integer should not be 0. The denominator should not be 0. So P by Q form is basically integer by integer form. So simply something by something cannot become a rational number. Now this 3 by root 2, 3 is an integer, but root 2 is not an integer. So though it is, you cannot say this is P by Q form. P by Q form meaning integer by integer form. So this one is not a rational number because root 2 is not an integer. This one is not integer by integer form. So it's not rational. Okay, we have to show that 3 by root 2 is irrational. Okay. So see here. So you need to do the regular proof, that is this one. If possible, let root 2 be rational. All this now. So till here till here you already know. Prove that root 2 is an irrational number. So till here you know. Now, hence to show that 3 by root 2 is also irrational. So this is how you continue. If possible, let 3 by root 2 be rational. If possible, let 3 by root 2 be rational. You know it is irrational, but if possible, let it be rational. Children, just a minute. There's somebody at the door. Just give me 2 minutes. Thank you once again, children. Yeah, so if possible, let 3 by root 2 be rational. Then if it is rational, 3 by root 2 will be of the form a by b, where a and b are co-prime integers. Now here what we're going to do is, this one is not going to be like this, not like this procedure. This one is different. Now, so if it is rational, then it has this a by b form. So 3 by root 2 is equal to a by b, where a and b are co-prime integers. Now cross multiply. Now here the intention is to separate the integers from the irrational. See, you know that root 2 is irrational, right? You know root 2 is irrational. So here the intention is separate the integers from the irrational. So you cross multiply. What will you get? Root 2a is equal to 3b. Okay. Now, you know this root 2 is the odd one out. Root 2 is the odd one out. Have that root 2 on one side. So take this a to the other side. So it will be 3b by a. So what have we done? In the left hand side, we have only root 2. In the right hand side, we have 3b by a. We have separated the integers from the irrational. We have separated the integers. Now, why a is an integer? Because a and b are, by the definition, a and b are co-prime integers. So a is an integer, b is an integer, 3 is also an integer. Now we know that integers, when you use integers, you can only get a rational number. Using integers, you cannot get an irrational number. Just by using integers, just use integers and tell me an irrational number. Not possible. You multiply, you divide, you do whatever, add, subtract, multiply, divide integers. The result is an integer. You cannot get an irrational number. When you perform any mathematical operation, addition, subtraction, multiplication, division, or a combination with integers, the result will be a rational number only. You cannot get an irrational number using integers. So which means 3b by a is rational because it's made up of only integers. 3 is an integer, b is an integer, a is an integer. 3b by a is made up of integers. And so 3b by a is a rational number because it's made up of integers. But on the other side, we have root 2. 3b by a we have on the right hand side. We have 3b by a on the right hand side, which is clearly rational because it's made up of integers. But on the other side, on the left hand side, we have root 2, which we know is irrational because we proved here. See, we know root 2 is irrational. Then how can it be an equality? When you say equal to, the left hand side is equal to the right hand side. An equality says that the left hand side is equal to the right hand side. But here we have a case where root 2 is equal. We have this one. Root 2 is equal to 3b by a, where root 2 is irrational, but 3b by a is rational. Root 2 is irrational. We know, we have proved root 2 is irrational. So on one side we have, that is, we have the equal to sign. It's an equality. On one side, we have an irrational number. On the other side, we have a rational number. How can an irrational number be equal to a rational number? So it's a contradiction. It's a contradiction. You cannot get a situation like this. You cannot get a situation like this and an irrational number is equal to a rational number. So this situation arises or happens because of our incorrect assumption. We assumed that 3 by root 2 is rational. That's incorrect. We started off incorrectly. That's why we get a situation like this, where on one side we have an irrational, on the other side we have a rational with an equal to sign. So I'll come again, children, from the beginning. If possible, let 3 by root 2 be rational. If it is rational, then it will have the a by b form. Now cross multiply and separate the irrational from the integers. So you can also write 3b by a is equal to root 2. Not that you must write root 2 is equal to 3b by a. You can also write 3b by a is equal to root 2. Anyways, so 3b by a is rational because a, b, and 3 are integers. So that means it means because it's an equality, that means the other side also should be rational. It's an equality, right? So that means other side, root 2 also is rational. But it's a contradiction. And this is because of our incorrect assumption that root 3 by 2 is rational. We started off saying that root 3 by 2 is rational. That's why this contradiction. Therefore, root 3 by 2 is irrational. We have a rational on one side. That means the other side also should be rational. Root 2 also should be rational. We have 3b by a on one side, which is rational. That means the other side root 2, because it's an equality, the other side root 2 also should be rational. No, but it's not. So this is a contradiction, and this is because of our incorrect assumption that root 3 by root 2 is rational. So therefore, 3 by root 3, oh my God, I've messed up, no? This is 3 by root 2, children. I've messed up everything. So that's what I was reading it. This is 3 by root 2. Here, children, this one is 3 by root 2. Typing error. 3 by root 2. Okay. This contradiction is due to our incorrect assumption that 3 by root 2 is rational. Therefore, 3 by root 2 is irrational. Do we understand this, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. Now, see, we need to read the question carefully. If the question is just show that 3 by root 2 is irrational, show that 3 by root 2 is irrational, then this is enough. This is enough. If you're asked to prove that root 2 is an irrational number, then you have to do this and this. If the question is only this, if this is the question, show that 3 by root 2 is irrational, then do only this. Only if you're asked to prove that root 2 is irrational, you'll have to work these two.
Ma'am, then can we directly say that root 2 is irrational if they ask only the second part?
Yeah, then you should say root 2 is irrational because we know that. Yes, this means root 2 is, that means because I told you, no, root 2, root 3, root 5, these are irrational is like a theorem. It's like a theorem. Now, for example, for example, we have a triangle. We have a triangle. And supposing this one is 40 degrees, this is say like 50 or 60 degrees. What's the measure of this angle? What's the measure of this angle? 80 degrees. Why? Because we know that the sum of the three angles of a triangle is 180 degrees. So we're using that result here. You don't have to prove that the sum of the three angles of a triangle is 180 degrees. So we're using that result here. Similarly, we know that root 2 is irrational. We know it's irrational. We're using that result here. So you can directly do it.
Okay, ma'am.
That's like a theorem now. It's actually a theorem. Root 2 is irrational. That proof that what you work as a theorem, you're proving the statement. Prove that it's like prove that the sum of the three angles of a triangle is 180 degrees. You prove that statement, right? So it's like a theorem and proof. In the same way, prove that root 2 is irrational. It's like a theorem and you're proving it. You're proving that statement by that's why it's called proof by contradiction. Proof by contradiction. So we take those statements as theorems. So you can do only this, wherein we know that root 2 is irrational because it's a theorem. Okay, so here alone there's a typing mistake, children. This one is 3 by root 2, as in the question. It's 3 by root 2. It's not root 3 by 2. It's 3 by root 2. Yeah, it's time to discuss the answers to statistics assignment. Please take a screenshot of this and complete this. Take a picture, all of you. Complete this in your notebook later.
Ma'am, we already wrote this in the notes you sent.
Yeah. Okay, then Tushita and Sashank. Please take a picture of this one and write it out in your notebook later. Okay. Later meaning at the end of the class, please finish it. Then we'll forget and Okay.
Yes, ma'am.
So now, Tushita and Sashank, please stay in the meeting. So you have not attended the classes on statistics. But whatever presentation you see, take a screenshot of that. So later when you complete the assignment, it will be useful for you to check your answers.
Okay,
So
ma'am.
from now till the end of the meeting, you may not understand what we are talking. That's okay. Just stay in the meeting and keep taking screenshots wherever needed. So once you learn up all that and you do the assignment, you will have the screenshots to check the correct answer. Check your answer with the correct one. All right. The others also, see, you may have not completed the assignment. I told you now I cannot force the assignment on anybody. You have to do the assignment for your good. Practice alone can make you perfect. You need to practice. Mathematics comes only by practice. The more you practice, the more confident you become. So that is why assignments are sent. You should find time to do the assignment. But again, I don't know the load of assignments you get from your school. So since we have students from a few different schools, some of us might have time, others might not have time, sufficient time. So I cannot impose it. Now I cannot question you why you have not completed, because I don't know your routine. I don't know the amount of time you spend at school, the load of assignments you get from school, and the other, whatever other things you'll have to do for the school. So since I don't know that, I cannot take you to task. I can't ask you why you have not completed. I can only ask you why you did not attend the class. If you miss my class, then I can ask you why you didn't attend. That's the only thing I can ask you. But that doesn't mean that you're let loose, meaning, okay, this lady is not going to ask us, so why do the assignment? No, be responsible. Assignments will be more interesting than the questions you see in the class. It will be a level more than what you actually learn in my class. Assignments are also, as you all know, these presentations are not, simply got from the internet and, pasted on the screen here. It's all done by me. I write all this. I make the presentations. It's my material here. So when I prepare the assignment for you, I prepare it a little more, a level higher than what I teach you in the class, so that you think, you're forced to think. It's not that you're just, writing whatever you understood in the class. There should be some, thought process. I should be invoking some thought process in you. So it will be a level more. So you will really be benefited by completing the assignments. See, I can't show you the benefit, but you will see the benefit in terms of your confidence and marks. Yeah. So it is good if you complete the assignments on time, good for you. So don't forget to take screenshots, all of you, and don't request for any answer later. Now ask me whatever you want. Yeah, so I'll start with mean. Tell me the first question. Let me check what you have in your book. Yeah. Yeah, class, use the emoji, raise your hand. Use the raise hand option and raise your hand, class. Prajit, Arjun, Madhumita, Danya, Shri Krishmi, Raghavi, Jayant, Sashank, Tanishka, Tushita, Lakshita, and Florentina. Are you there? Florentina, I've not heard from you in this class. Okay, Tushita is there. Okay. Florentina. All right. All right, children. Fine. Now, class, I want you to read out the first question. How many of you have completed the assignment? Let's not waste time, please.
Ma'am, I think we have already discussed the mean assignment.
Oh, mean we have already discussed. You have the screenshots, sir, Rakshita?
Yes, ma'am.
Okay, Rakshita, read out the first. It's okay. Maybe it will benefit the others who have not taken, or Tushita and Shashank can take it now. Rakshita, what's the first question in your book?
Ma'am, find the mean of 5 observations in 15 and that of another 10 observations. That question.
Just a second. There's some glitch. Just a second. Yeah. Because okay, I think that's right in front. So do you have these questions? I think I had uploaded these, no, in the documents tab, right?
Yes, ma'am.
Yeah, no, let me do one thing. Yeah, mean Rakshita says we've already discussed, so let me not waste time. Sashank and Tushita, please stay back after the meeting. I need to show you something which you should be able to access with your credentials. Please stay back after the meeting. Sorry, Tushita and Sashank.
Okay, ma'am.
Yeah. Yeah, start taking screenshots. Those who need. These are the questions. This is the answer for the first one. If you're not able to take a screenshot, then this recording, you should use the last part of this recording to see the answers. The recording is always there with you. So you need to use this recording and, forward the video to the last 15 or 20 minutes and see the answers from here if you're not able to take a screenshot.
Ma'am, can you please show the previous slide?
This one?
Yes, ma'am. Thank you, ma'am.
Sorry. After this one is this. That's about mean. Next, median. Rakshita, median we have to discuss, right?
Yes, ma'am.
Okay, very good. Rakshita, what's the first question on median?
1 minute.
Yeah. Anybody can say, but since Rakshita is communicating with me, I'm asking her. It's for the class, not only for Rakshita.
The
Anybody
following
can say.
numbers are written in descending order of their values.
Very good. Okay. I just want to check if it is this one, that's all. These are the questions, right?
Yes, ma'am.
Yeah, Tushita and Sashank. As I told you, you can use the, if you're able to take a screenshot, fine. Otherwise, you can use the last part of today's meeting, which will be given to you.
Okay, ma'am.
Okay, ma'am.
Yeah.
I'm going to show the previous slide.
Yeah. Yeah, what's the answer for the first one? What's the value of X? What's the value of X?
48.5, ma'am.
48.5. Very good. Rakshita, very good. Take a picture, all of you. Yeah, what's the median weight? Nobody has done the assignment. See, I'm studying like as if I'm a 10th standard student. I prepared all these questions for you. Huh? The effort I have taken, you people have not taken.
Ma'am, I'm getting 52.
52. Very good. Rakshita, again, very good. 52. Take a picture, all of you. Yeah, answer for this. Why I'm not hearing from the others? Huh? Don't force me to punish you. You had such a long time. Some of us are also in vacations. You've not started your classes. What's the answer for this one? Median age.
15, ma'am.
15. Oh, very nice. Very good. See, it's Rakshita again. Only she's completed the assignment. Next one.
Uh, 67.5, ma'am.
Oh, I'm getting 58.75.
Okay, ma'am, I'll check it once.
Yeah. Let me know. See, calculation error is human, no? So even I could have gone wrong somewhere in calculation. So Just let me know if you find out something. 58.75 is what I'm getting. Next, find the value of x. Very good, Rakshita. So happy.
Thank you, ma'am.
Yeah, very good. What's the value of x here?
Ma'am, here I was a bit confused, so I left it.
Okay, fine. All right, I'm getting 12. I think this one, the other day, Madhumita asked me in the class. I remember she asked me, and yeah, this is the answer.
Okay, ma'am.
Yeah, x is 12. It's all about, calculations, simple calculations, but somehow we go wrong. Somehow we can go wrong. You need to, now you'll just think, what is this? Just formula, substitute the values and work. There, see, everything will be right till here. Substituting in the formula also, you'll be right. Somewhere here we go wrong in calculating. And you'll end up with some decimal value, because frequency has to be a natural number. Frequency, the number of times, 1, 2, 3, 4, 5, 6, it has to be a natural number. You cannot get a fraction or a decimal value like 12.35. You cannot get all this for frequency. Number of students, no? So number of students, you cannot get 12.35 students. So you have to be very careful while calculating, and for that you have to do the assignment. X and Y. What are the values of X and Y? Notita has done it. X is 38. I'm getting X 38 and Y 29. X is 38 and Y is 29. So in the class, I wouldn't have given you fractions, mixed fractions for median. Assignment, you will get such questions. That's what I meant by saying assignment will be a little more than one level more than what I really do in the class. See, the concept, all the concepts will be delivered. That I'll not do like school, you learn something else happens in the test. No. I'll teach everything is given in the classroom. Everything that's needed to complete the assignment is taught in the classroom. What I do, instead of giving a whole number, like if 57 is the median, I give a mixed fraction like this. That's all. That's the only variation. But that becomes a little difficult or tricky to work carefully. That's what I meant. All the questions in the assignment, the concept or the knowledge needed to do the assignment is given in the class already. None of these questions are new.
Ma'am?
Yeah. Yes, Rakshita.
Ma'am, I have a doubt here, ma'am. Ma'am, can you tell me once again how to choose the median CI?
Yeah, sure. So the median, the value of the median here is 57.2 by 19. 57.2 by 19 is like 57 point something. 57.2 by 19 is a mixed fraction. So 57.2 by 19 means 57 point something. So clearly it lies between 50 and 60. The value 57.2 by 19 means 57 point something. So clearly this lies between 50 and 60, the class interval 50 to 60. Is that what you wanted, Rakshita?
Yes, ma'am. Yes, ma'am. That's why.
Yeah. Median marks. The value of the median is 57.2 by 19. And that value lies in the class interval 50 to 60. So the median class interval is 50 to 60.
Yes, ma'am. Now I'm clear.
Very good. Yes. F1, F2?
Ma'am, I'm getting it as 25 and 35.
Very good. Very good, Rakshita, once again. 35 and 25. Missing frequencies A and B? Now, others don't console yourself saying that nobody did the assignment. Only one girl did. That's the reason, we give our parents. Nobody did. Nobody has time to do the homework. Only one girl had done. Maybe she had a lot of time to do. So see, one of your peers has completed it. So you must ask yourself, why not me? Even she studies the same subjects you study. So that should be the motivating factor for you. I will not force you. You should force yourself to do it. I'm not forcing you. You must force yourself. You must now ask this question. When my friend Rakshita was able to complete the assignment, why not me? I study the same subjects as she studies. Then why not me? So that effort you have to take. Maybe Rakshita completes everything, but at least you achieve 50% of that. So you need to get motivated from your friend. Don't find lame excuses for not doing it. Find a reason to do it. Find a reason to be responsible. A and B, values of A and B.
Ma'am, I'm getting some value in point, but it's wrong. That's why.
Okay. 20 and 30. So Rakshita, please check your answer with, what you see here later and let me know, okay, if you were able to identify your mistakes. Otherwise, ask me in the next class. Supposing something is not
Yes,
clear, yeah, make a note of the questions. Like, for example,
Yes,
median
ma'am.
question number 8, make a note of the questions and ask me in the next class.
Okay, ma'am.
Yeah. So that's about median, children. I know it's time. I'll just show you the answers for mode and we'll wind up the session for today. Yeah. These are the questions.
I'm going to show the previous slide.
Yeah. Yeah. 1. Since it's time, children, now I just want to talk about this term average. Okay, remind me in the next class. I want to say something about this question. Find the average height of maximum number of boys. Please remind me.
Yes, ma'am.
Yeah. So for question number 3, the value of mode is 24, 4 by 19. Is it right, Rakshita? Were you able to complete the questions on mode, Rakshita?
No, ma'am, I've done until the 4th question. I'll complete it by this weekend.
Okay, fine. All right. Okay, then what's the answer for the 4th one?
Ma'am, I'm getting it as 1847.82. I'm getting.
How nice. Very good. 1847.83. Very good. Yeah. From here, all of you continue to take the screenshots. One minute. Here again, I've gone wrong in typing the question. What is the question? Oh, there's something. This is incorrect. Oh, I have to change this one. This is the question. This is the question. The table is given. This is the question, children. The following table shows the expenditure. Is this a question? No. Just help me. Let me correct this. Let me correct this one, children. No, the answer is right, but the question is different. That's why I've just messed up the. I've not matched the question and answer correctly. Just ignore this. I'll show you in the next class. Yeah. This is the 8th one. Nine. As I told you, I'm repeating. You can use the last 20 minutes of this meeting recording to see the answers. All right. That's it about the assignment. Okay, so all right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call. Tushita and Sashank, 2 minutes. Please stay back. Yeah. Thank you, children.
Okay.
Good night. Yeah.
Thank you, ma'am.
Thank you, children. Good night. Good
Ma'am,
night, children. Thank you. Thank you, children. Good night. Thank you, Krishmi. Good night.
ma'am,
Yes, Raja?
ma'am, need to talk regarding the school examination.
Yeah. Raja, can we connect over a call?
Yeah, ma'am.
Yeah. I'll just call you back. Can I call you at about 9:50?
Yeah, ma'am, sure.
Okay, yeah. Thank you.
Thank you, ma'am.
Yeah, Sashank?
Yes, ma'am.
Yeah, you've got the credentials, right?
Yes, ma'am.
Yeah. So what you have to do is, in your browser, you're using a laptop, tablet, or mobile phone?
Laptop, ma'am.
Laptop. So now go to the browser, open the browser, Chrome or whichever
Yes, ma'am.
browser you use, open the browser.
Yes, ma'am. Open.
Okay, there you type atharv.testpress.in.
I'm already logged in, ma'am.
Oh, you already, okay. No, some of us are not able to figure out as to how to log in. Okay, so you already logged in, right?
Yes, ma'am.
Okay, that's nice. Okay, now let me tell you something more. Just a second. So can you see my screen, Sashank?
Yes, ma'am.
Yeah. Now you will not have all these tabs. You will have only the exams tab, documents, and one more you will have. I think analytics.
Yes, ma'am.
Yeah, you will have only those 3 tabs: exams, documents, and analytics. So in exams, you know, you will have 3 sub tabs like running, upcoming, and completed. So running meaning exams that are running now, which you can take up. Upcoming
Yes,
is exam. I think I'll just stop the meeting recording and continue. Just a second.